Recrystallization is a means of purifying a solid. It relies on a difference in the solubilities of that solid and any impurities in it in a solvent or a mixture of solvents. The aim of this process is to separate the purer solid in a crystalline form from insoluble impurities, which are filtered off, and from other impurities which will remain in solution. This program is intended to show you the basic techniques of this process. As you proceed in your chemistry course, you will come across recrystallizations that will require you to modify these techniques to allow for a particular situation, for example, smaller scale recrystallizations. We will first show you the technique required to find a suitable solvent with which to recrystallize a pure substance. Take a small amount of the sample to be recrystallized on the end of a spatula and place it in a small test tube. Using a clean pipette, add one of the solvents suggested in the experimental notes. If the substance dissolves at room temperature or on gentle warming, discard this solvent. It cannot be used for the recrystallization. Using another clean pipette, transfer another of the solvents in experimental notes onto the sample. If the solid is insoluble at room temperature, place the mixture in a hot water bath and bring it to boiling. Only if you use water as the solvent for recrystallization may you use a microburner. If you use water, then this must be done in a fume cupboard and well away from anybody using flammable solvents. To return to our other sample, if it is still insoluble even after boiling, then again this solvent is no use for recrystallization and must be discarded. Repeat this process with yet again a fresh pipette until you find a solvent in which the solid is insoluble at room temperature. But which dissolves on gentle boiling. Allow the solution to cool to room temperature. Immerse the tube into an ice bath and shake it gently. If crystallization does not occur quickly, the process may be hastened by scratching the inside of the test tube with a glass rod whilst cooling the mixture. If the solid crystallizes after this process, then this solvent is useful for recrystallization. In order to recrystallize the bulk of your sample, set up the apparatus as follows. Place a 250 milliliter round bottom flask in a clamp and insert into the neck a condenser, running a gentle stream of water through that condenser. Then place the bulk of your sample into the flask. The procedure that you see here is recommended for experienced workers only, those with steady hands. It is recommended that you use a funnel or powder funnel in order to add the solid to the flask, in order to avoid spillage down the side of the flask. Measure out a volume of the solvent which you found was useful for recrystallization. So that you may determine afterwards how much of that solvent you used. Pour sufficient solvent through the condenser in order to wet the solid well. Turn on the heating mantle and bring the solvent to the boil. If the solid doesn't dissolve completely after a minute or two under reflux, then you must add a little more solvent through the condenser. Bring the solution back to the boil and observe whether the solid has gone into solution completely. Allow the solution to cool first to room temperature, then cool it in an ice bath with occasional swirling in order to induce crystallization. Again, if crystals do not appear rapidly, you will have to resort to the use of scratching the inside of the vessel with a glass rod. This may take a little while to induce recrystallization, but do not be impatient and do not poke the glass rod through the bottom of the flask. Once crystallization starts, leave the flask in the ice bath in order to complete the process. It will be necessary to clamp it to prevent it falling over. If any difficulties are encountered at any stage of recrystallization, consult a demonstrator, or read page 111 of Vogel's Textbook of Practical Organic Chemistry, which is located on the bench next to the demonstrator's desk. Whilst waiting for the crystallization process to complete, set up a filtration apparatus as follows. Place a Buchner flask onto a clamp in a retort stand and put a rubber seal into the flask. Put a piece of filter paper of the correct size into the Buchner funnel and insert that into the rubber seal. Connect the Buchner flask to the water pump, ensuring that the tap on the trap of the water pump is closed. Pour a little of the supernatant of the recrystallization onto the filter paper in order to damp it and to fix it to the bottom of the funnel. Turn on the water pump and transfer the mixture with shaken to the funnel, ensuring that as many of the crystals go into the funnel as possible. Open the tap on the trap and wash the crystals with a little of fresh solvent which has been pre-cooled in ice. This removes any traces of mother liquor left on the crystal surface. Close the tap of the trap and allow the crystals to suck dry in air. Scrape off the crystals from the filter paper into a suitable receptacle such as a recrystallizing dish or a beaker. Open carefully a desiccator. Put the crystals in the dish inside the desiccator, slide the lid back on, and leave the crystals to dry overnight. Sometimes it is difficult to find a single solvent from which you can recrystallize your solid. In this case we resort to a mixture of two solvents. If, however, the two solvents prove to be immiscible and form two layers, as in this case, then they cannot be used for recrystallization. The solvents must be completely miscible. As in this case. Thus the solvent mixture on the right could be used for recrystallization, but the one on the left cannot. In order to recrystallize the bulk of your sample, set up the recrystallization apparatus as before and put the solid into the flask. Again, this requires some expertise, and you'd probably be better to use a funnel to put the solid into the flask. Dissolve the solid in about 2 to 3 times its volume of the solvent in which it is completely soluble at room temperature. And bring this solution to the boil. To the boiling solution, you can see here the solvent is dripping from the bottom of the condenser. Add the solvent in which you have previously found the solid to be completely insoluble. This may take considerable solvent. It depends on how much of the original solvent in which the solid was soluble you used. When you see a turbidity in the solution, bring the solution back to the boil. If the turbidity persists even on boiling, you have added enough of the second solvent. You then add a trace of the first solvent such that the turbidity just clears. The solution is then left to cool and crystallization is induced as before. In this case, the solution was left overnight at room temperature and the result was these rather large crystals. In our final sample, there is an insoluble black impurity. In your preliminary test to find a suitable solvent, you will have to judge whether the soluble material has gone completely into solution. On the right is the mixture before heating, on the left after heating. Before recrystallizing the bulk of your sample, prepare a fluted filter paper as given in Vogel's textbook of practical organic chemistry. Place the fluted filter paper in a gravity funnel which has been pre-warmed in an oven. Put the funnel into the neck of an Erlenmeyer flask and clamp the whole apparatus in a hot water bath in order to keep it warm. Set up your recrystallization apparatus as before. Again, use a funnel for this transfer. Bring the mixture to the boil as before. Turn the heating mantle off, lift the apparatus from the heating mantle, and carefully remove the condenser from the flask, remembering that it may be hot. A piece of folded up filter paper is useful in handling the hot glass at this stage. Put the flask back into the mantle briefly to rewarm it. Pour a small amount of the hot solution into the fluted filter paper. Replace the solution in the mantle to keep it warm. Filtering in small portions helps prevent the insoluble material from creeping up the side of the filter paper and over the top and back into the Erlenmeyer. It also helps prevent crystallization occurring in the neck of the filter funnel. Repeat the process of pouring small portions into the fluted filter paper until the filtration is complete. The soluble material should then have gone into the Erlenmeyer, and the insoluble impurity remains on the filter paper. Allow the solution to cool and induce crystallization as before. Again, these rather large crystals are the result of a slow crystallization overnight. Large crystals do not necessarily mean a purer compound, because solvent and impurities can get trapped in the crystal lattice. The purity of a product is determined by the melting point. In order to measure this, put a small amount of your solid onto a porous tile and crush it with a spatula. Charge the solid into a small melting point tube and force it to the bottom of the tube by tapping the tube on the bench. Do not do this too vigorously, otherwise the tube may break. Insert the melting point tube into the melting point apparatus. Switch the heater on and set the control to a moderate value. You may then determine the point at which the solid melts. Because of the variation in amount and purity of samples which you may have to recrystallize, you will have to adapt these basic techniques throughout your chemistry course to the particular need that you will find. And to master all aspects of recrystallization, you will require plenty of practice.